Assistant Professor in Aeronautical Department, PSNC in Tirunelveli. Today I discuss about the topic aircraft fundamentals. First one, aircraft versus airplane. Aircraft means fly anything in the air is called a aircraft. Airplane means this is a powered fixed wing aircraft that propelled thrust by it produces a thrust. Aircraft is capable of flying through the air. Example: aeroplane, helicopters, gliders, drone, airships, and hot balloons. Airplane means a powered fixed aircraft that propelled forward by a thrust. Example: fixed wing. A engine typically has a fuselage, cockpit, tail and landing gear. Types of aircraft. First one is powered aircraft. Second one is unpowered aircraft. Powered aircraft is different at to produce a powered control. First one is fixed wing. Use the wing and engines to generate a lift and thrust. Example: Boeing 747, Cessna 172, Airbus A302. Rotary wing, that means of helicopters, use the rotating blades or rotor to generate a lift. Example: Bell 206. Next one, type rotor aircraft. Combine features of airplanes and helicopters. Example: V-22 Osprey. Second types of powered aircraft is unpowered aircraft. That means of glider. Glider is a no engine in aircraft. Military aircraft. The fighter jet. Compact air superiority. Examples: F-22 Raptor and Suzuki 35. Boomers is a long range attack. Example: B-2 Spirit, B-52 Stratosphere. Next one, transport aircraft. Cargo and trapdoor movement is called a transport aircraft. Example: C-17 Global Master 3. Second one, surveillance. Intelligence to gathering information in transport aircraft. Example: U-2 E-3 Sense. Next topic, commercial aircraft. Commercial aircraft are airplanes designed to carry passengers and or cargo for profit. They are used to airlines and cargo operates for domestic and international airport. This aircraft are certified by aviation authorities like FAA, EASA, DGCA for commercial usage. Second one, aviation aircraft. In terms of aviation aircraft, it broadly refers to any flying vehicles used in field of aviation, including those for military, civil, and especially the purpose of applications. These aircraft are designed for transportations, surveillance, training, and recreation and more. Next topic, the civil aviation. It is used for a non-military purpose like a passengers travel and cargo. Example: Boeing 737, Boeing 787, Airbus A320, A350. Next topic, the military aviation. Military aviation aircraft. It is used by armed force of compact transport, surveillance, and supports. First one is fighter aircraft. Example: F-22 Raptor and Rafale. Second one is transport aircraft. Example: C-130 Rafales, C-17 Global Master 3. Next topic, boomers. Examples of P-2 Spirit and P-52 Stratofortress. Second one, helicopters and drones. Example: AH-24 Apache, that means of attack helicopters, MQ-9 Raptor for drone. Next topic, the aircraft components. First one, there are 5 types of aircraft components in aircraft. First one is fuselage, second one is tail sections, the third one is landing gear, fourth one is control surface, and final one is wing. Fuselage is the main body of the aircraft. Fuselage function of cockpit, passenger cabin, cargo hold and avionics. It provides a structural connection to wing and tail. There are 2 types of structural design in fuselage. First one is monocoque and second one is semi-monocoque. Wing is it is generate a lift through their aerofoil shape. It houses the fuel tanks and sometimes the landing gear. May include flaps, ailerons and spoilers. There are 2 types of wings. First one is cantilever, second one is structural based wing. Next topic, tail sections. It is called as a tail assembly. It includes a horizontal stabilizer, vertical stabilizer. For horizontal stabilizer, it controls the pitch stability. Elevator moves up and down to control a pitch. Vertical stabilizer, it maintains a yaw stability. Radar means it controls a yaw motion, left or right movement of a nose. Power plant. It is a function to provide a thrust for forward motion. The power can be a hydraulic, electrical and pneumatic system. There are 3 types of power plant system. The first one is turbofan, second one is turboprop, third one is piston engine. Turboprop examples airliners like Boeing 777, turboprop example ATR 72, piston engine Cessna 172. Next topic, landing gear. It supports a aircraft during a landing, takeoff and ground operation. It can be fixed or retractable in landing gear. There are 2 types of landing gear. Tricycle landing gear. Second one is dragger landing gear. Cockpit. It contains a flight instrument navigation system, engine controls and communication system. It location where the pilot control the aircraft. Control surface. It controlled by a surface is called a control surface. The control surface are movable parts of aircraft structures that allow the pilot to control its attitude and direction during a flight. This surface manipulated a pitch, roll and yaw to ensure a safe and stable flying in a aircraft. Aileron. It controls a roll movement. It operation when the right ailerons goes up and the left ailerons goes down. A casing of the aircraft to roll the right and by voice. Location. The trailing edge of each wing near the tips, wing tips in the aileron. Aileron functions. Elevators. It controls a pitch nose up and pitch nose down. The operation pulling the control sticks backward rise and the elevator lifting the nose. Location on the horizontal stabilizer at the tail. Radar. It controls the side to side motion of the nose. It operation the pressing the left radar pedal moves the radar left and turning the nose left. Location on the vertical stabilizer. Next one, secondary or high lift control surface. Its function can be increasing a lift and drag at lower speed, like takeoff and landing gear. Its location in a inner trailing edge of the wing. Its operation can be delayed on downward to increasing a wing cam. Next one, spoilers. It can be reduce the lift and increasing the drag, assisted in descent and braking. Its location can be top surface of the wings. Its operation can be upward into a airflow to the spoil the lift. Next one is salts. It functions increasing a lift during a low speed flight. Location, it can be a leading of the wing. The operation to extend a forward to allow the smoother airflow over the wing at a high angle of attack. Next one, the trim tab. Trim tab, it can be reduced the need for constant control input used for a fine adjustment. It located on trailing edge of a control surface like a elevator. Its operation can be set to hold a control surface slightly deflected. Aerodynamics force. When the aircraft moves through the air, the four primary aerodynamics force act on it. These are the force to determine how the aircraft behaves with the aircraft. There are four forces acting in a aerodynamics force. First one is thrust, second one is drag, third one is lift, final one is weight or gravity, center of gravity. First one, lift. Lift is a upward force of aircraft. It can be produced by highly produced by a lift. It is the definitions in the force that can be support the aircraft in the air, acting perpendicular to the direction of flight. It can be generated in wing sections. How it's work in the basic principle of Bernoulli's principles and Newton's third law of motions. The air moving faster over the curved top of the wing creates the lower pressure and resulting in upward lift. Next one, the weight. Weight is a downward force. The gravitational force pulling the aircraft towards the earth. It acts can be downward through the aircraft's center of gravity. Depends on a mass of gravity and mass of aircraft and gravity. And W is equal to mg. Thrust is a forward force. The force that can be propelled the aircraft forward, which is generated by the aircraft engine like propeller, jet engines and turbofans. It is a directly acting direction of motions. Drag is a backward force. In the distance of force offers or opposite direction of the thrust force. The aircraft motions through the air. Types of parachute drag. First one is parachute drag due to a space and shape and surface. Second one is induced drag due to a lift generation. It's at a opposite to thrust. How to produce the lift? Lift is the upward force that allows a aircraft to rise and stay in the air. It is generated primarily by the wings as airflow over them. Lift equations. L is equal to 1/2 rho v squared SCL. L means lift force, rho means air density, v means velocity of airflow, S means wing surface area, CL means coefficient of lift, depends on airflight and angle of attack. Angle of attack and stall. The angle of attack is the angle between the curved line of the wing and an imaginary straight line from the wing leading edge to the trailing edge and ongoing of airflow, that means of relative wind. Alpha is equal to theta into rho. Alpha means angle of attack, theta means pitch angle of wing or aircraft fuselage between the curved line and horizontal. The flight path of angle between a relative airflow and horizontal. Stall occurs the angle of attack exceed the critical angle, that means of usually between a 15 degree to 20 degree, depends on a wing designs. The casing of sudden loss of lift. Second one, is aspect ratio. The aspect ratio is the measure of wings, spindles and it is defined as the ratio of wingspan to its average curl. It is an important aerodynamics parameter, efficiency, lift, drag and aircraft performance. AR is equal to B by C. B means wingspan, C means mean aerodynamics curl. Aerofoil. The aerofoil is the cross-sectional shape of wing, blades or sail designed to produce a lift where the airflow over it. The types of airfoil: symmetric airfoil, camber airfoil, supercritical airfoil, reflexed airfoil, thin airfoil, high lift airfoil. First one is symmetrical airfoil. The upper edge and lower surface are a mirror image of the symmetrical airfoil. The characteristics like the zero chamber, it generates a no lift and zero angle of attack. It produces a lift increasing symmetrically with positive or negative angle of attack. Second one is chamber airfoil. For it is a upper edge is more curved than the lower surface, like a positive chamber. It is generate a lift at zero angle of attack, more efficient at low speed, and it can be produce a higher lift to reduce drag ratio compared to a symmetrical airfoils. Third one is supercritical airfoil. It is flattened upper surface with pronounced chamber near the trailing edge. It is designed to delay the shock wave formation at a transonic speed, like a Mach number 0.821. They reduce the drag rises near the speed of sound. It improves the fuel efficiency at a high subsonic speed. Reflexed airfoil. It can be a chamber curve bends upward near the trailing edge. It characteristics like it can be provides a balancing moment that reduces a nose down pitching. It can be useful for tailless aircraft and flying vehicle.